Stepper motors are classified as brushless DC electric motors that divide full rotation into an equal number of steps. They are used in many applications in our daily lives that include CD players, electric tools, and automation equipment. As the name suggests, each pulse of electricity produces one step of rotational motion. For this exercise, we'll discover the basics of stepper motor technology, beginning with the brushless DC motor. Unlike DC brush motors, DC brushless motors do not utilize brushes to control current. Permanent magnets bonded directly to the rotor of the brushless DC motor create rotational motion as current passes through the stator. A rotating magnetic field is formed by electrical pulses generated by a converter. As the rotor turns, a rotor position sensor provides feedback to the converter so the required stator field rotational sequence is maintained. The change in sensor state reports back to the converter, which continually switches the phase to the windings to keep the motor turning. The sequence is further explained here when the Hall effect sensors turn on. Coils are energized by the converter. The coils alternate in order, creating the magnetic field to turn the rotor. The sequence is repeated with the next set of Hall effect sensors and coils to continue rotation. With the DC brushless motor being the foundation of stepper motors, let's look at how the stepper works. Stepper motors are so named because each pulse of electricity turns the motor one step. A simple stepper motor system is comprised of 4 elements. The user interface allows the operator to input motion parameters such as speed, distance, and direction. Examples of an interface would be a programmable logic controller or data entry terminal. The indexer converts the data input from the user interface to motion signals that the motor will turn to a defined position and speed. The driver then takes the data from the indexer and provides current pulses to the motor. The number of steps the motor turns is equal to the number of pulses transmitted to the driver. The stepper motor is a brushless electric motor that converts pulses into mechanical shaft rotation. Each pulse moves the shaft through a fixed angle defined by the multiple toothed electromagnets arranged around a gear-shaped rotor. Stepper motors have 3 step modes of operation that include full, half, and microstepping. The type of step mode output of any stepper motor is dependent on the design of the driver. The driver also controls both the step angle and speed of the motor by switching the field coils in a set sequence. For full step mode operation, energizing each set of coils sequentially, the rotor can be made to rotate or step from one position to the next by an angle determined by its step angle. Shaft rotation is achieved by energizing both windings while reversing the current alternately. Switching coils A, B, C, D, one coil at a time repetitively, will rotate the rotor in the forward direction. In this example, there are 6 steps arranged on the rotor 60 degrees apart. 24 steps are required to make a full rotation at 15-degree increments. For half-step mode, the stepper motor's resolution can be doubled by altering the switching of coils. Half-stepping occurs when one winding is energized and then 2 windings are energized alternately, causing the rotor to rotate at half the distance. Switching coils in this combination will rotate in the reverse direction. As you can see in this example, 48 steps are required to make a full rotation at 7.5-degree increments. Microstepping controls the current in the motor winding to a degree that further subdivides the number of positions between poles. To achieve microsteps, the coils are only partially energized. As we apply a maximum voltage of 5 VDC to coil A and a minimum voltage of 0 VDC to coil B, rotor position 1 will line up. Reducing the voltage to coil A and increasing voltage to coil B, the rotor will begin to rotate in a clockwise direction and continue until the voltage is 0 at coil A and 5 at coil B. This process continues at all coils within the stator to provide accurate positioning. As you can see in this example, 120 steps are required to make a full rotation at 3-degree increments.
Grabando. La puta es que está al revés.
¿Has traído algo? ¿Has traído algo?